Good day everyone. In this video, let us discuss on how to calculate or how much force experience on a moving charged particle in the presence of the magnetic field. Meaning we'll introduce a theory on how to calculate the amount of force on the charge if we place the charge in the presence of magnetic field in space. Now, before that, let us have the similarity of the electric field and magnetic field, and also the differences of the two quantities. Now, take note that in our lecture of the electrostatics, that the electric field, which is the result of the charge distribution of a source charge particle, exerts a force on the charge. Meaning, if we place a charged particle in the presence wherein there is a magnetic field, that charge experience a force. We call that as electric force or electrostatic force. So, for example, if we have the electric field directed towards right, and if we place a charge on that region wherein there is an electric field, this charge with the charge Q experience a force, and the force is directed towards the electric field. For positive charge, the electric force is directed towards the electric field, and the magnitude of this force is the product of the charge Q and its electric field, which means that this electric force is directly proportional to charge and electric field. Hence, the electric field can be calculated if we divide the electrostatic force on the charge divided by its charge. Now, if we have a negative charge placed on the electric field, the force is opposite to the direction of electric field, because the charge is negative. And still, the magnitude of the force, which tends to move away from the electric field, is also directly proportional to the charge and electric field, because the force again is the product of the charge and electric field. Now, what about in magnetic field? The magnetic field exerts a force, magnetic force, on a moving charges, meaning there must be a magnetic force if that charge travels in the presence of magnetic field. So if we have this charge travels on the region wherein there is a magnetic field towards right direction, for example, then this charge with velocity in this direction must have the magnetic field on it, and that velocity and magnetic field on the charge will result magnetic force, which means that the magnetic force is proportional to the velocity and magnetic field. Another thing is the direction of the magnetic field is always equal or always perpendicular to the normal of the plane velocity and magnetic field. And take note that we have here the angle between the velocity and magnetic field, and we call that as P angle. And notice that the angle is coming from the velocity towards the magnetic field, because the velocity vector will interact to the magnetic field, and the interaction results magnetic force. And that magnetic force is always perpendicular to the plane generated by the velocity and the magnetic field. The velocity interact towards the magnetic field, and we call that as angle P. Now, if this particle travels in a reverse direction, then notice that the magnetic force is also reverses its direction. And notice also that the angle from velocity to the magnetic field changes, which means that the direction of the velocity matters with magnetic force. So in this video, let us provide how to calculate the amount of force because of the velocity and magnetic field interactions. Remember that the interaction of the velocity particle and its charge towards the magnetic field results magnetic force. So the question now is, how much force and what is the direction of that force? What is the relationship of the force towards the charge, and what is the relationship of force towards velocity, magnetic field, and the angle between the velocity and magnetic field? And notice that this problem is a kind of a three-dimensional problem, because the velocity and magnetic field are lying on a plane, and the force is perpendicular to that plane. So it must be a three-dimensional problem. Okay, so let us now have, what is the formula? How to calculate the amount of force. So consider again the magnetic field towards right, and we have the charge travels with velocity v. So therefore, since there is a velocity and we have the magnetic field, then we have the force. The question is, if this force travels with velocity in the presence of magnetic field, how much magnetic force experienced on the charge? So again, this charge, because this charge travels in the presence of magnetic field, then this must be experience the magnetic field while traveling. And this one, the velocity and magnetic field, has an angle of P, which means that this is the plane that the velocity and magnetic field interacts, and we have that angle P. And the angle, remember, is coming from velocity towards the magnetic field. It cannot be reverses. It's always from velocity towards the magnetic field. So therefore, there must be a force on it in the third dimension, because velocity and magnetic field are on two axes. Then normal to that is the direction of velocity on a magnetic force. Okay, so again, if it reverses, then we have the reverse direction of the force. So the question is, how much force experience on the charge? And the formula says that the magnetic force vector is equivalent to the product of the charge, its charge, times the cross product of the velocity and magnetic field. Remember, cross product matters with orientation, which means that we cannot reverse the velocity and magnetic field. It should be velocity cross B, because if you reverse it, it's different from the definition. So it is coming from the velocity, will take the cross product of that towards the magnetic field. That's why the angle must be coming from velocity towards the magnetic field. So to calculate the magnitude of the magnetic force, just take the absolute value of this charge, meaning if this is negative, consider only positive. But in a vector, you have to consider it. If it is positive, do it positive. If it is negative, do it negative. And that is for vector. But for the magnitude of the magnetic force, just take the absolute value of the charge, then multiply. Remember the cross product in a vectors analysis. The V cross B is the product of the magnitude of the velocity and the magnitude of the magnetic field multiplied by the sine function of the angle from the velocity towards the magnetic field. Okay? So, why is it sine? Sine because this is cross product. You have to recall your vectors analysis. So, magnitude is absolute value of Q, velocity, magnetic field times the sine function of V. Where F is the magnetic force, or we call this as Lorentz force, and the unit should be Newton. The charge is Q, This is, take note, this charge is a single charged particle. We analyze only how much force on a single particle. And the answer is, this is the formula. The velocity, V, is meter per second in unit. The magnetic field is Tesla, or big letter T. And the angle, this is very important, the direction of velocity towards the magnetic field. So it should coming from the velocity from velocity towards the magnetic field. And the unit should be in degree. So the angle, again, is coming from the velocity. This is erroneous. From velocity towards the magnetic field. Okay, now, there is another unit of magnetic field. We call this as Gauss. So sometimes you will be given or encounter problem wherein the magnetic field is expressed in terms unit of Gauss. So we have 1 Gauss, or big letter G, is equivalent to 10 raised to 4 Tesla, which means that the 1 Gauss, or 1 G, is just equal to 10 raised to the 4 big letter T, or Tesla. Okay, so we are now ready to solve problems. So again, if we have x, y, z as the Cartesian coordinate system in space, then we have this charge Q. Now, suppose this charge experience a force, a magnetic field towards positive z-axis. The question is how much force experience on the charge. Now, remember that if this charge is stationary, then there is no force. So the requirement of having force on the charge, it should have velocity at that instant. So therefore, this charge experience this magnetic field, the same magnetic field that given the surroundings. So at that point, the magnetic field is B. And suppose this charge travels towards positive x. Take note that the formula says that the force on that charge is equal to the product, because there is a presence of 3 particle components. We have the Q, we have the velocity, and we have the magnetic field. Then we have to take the cross product of this velocity towards the magnetic field multiplied by Q. Okay, now remember that all of this except the charge are vectors. So meaning, in order to use this formula, you have to express the velocity in terms of unit vector. And also with express this magnetic field in terms of unit vector. So if this figure is based on the problem, now then it follows that this velocity in terms of unit vector, this is equivalent to the magnitude of velocity multiplied by I, because this is towards positive x, I hat, while the magnetic field vector is equivalent to the magnitude of that magnetic field multiplied by the unit vector, which is directed towards z-axis, so we can put it in positive k hat multiplied by magnitude, and we have this, the magnetic field. Okay, now remember that this is exactly towards positive x and this is exactly towards negative z-axis. Then the angle must be what? Must be 90 degrees. So if this is the problem, then how much force and what is the direction of that force? So remember that in our lecture a while ago, that the force is always normal to the area generated by the velocity and magnetic field. Meaning, we have this plane which is xz plane. So if this is xz plane, the velocity and magnetic field are line, then normal to that is towards y. The question is it towards positive y or towards negative y? Okay? So if we follow the formula and substitute the velocity vector and the magnetic field vector, multiply it with the charge, then you will arrive mathematically the magnitude of that force and its direction. So to do it is, of course, we want to know how much this force. To answer is, use the formula, because the question is how much magnetic, how much is the magnetic force vector. So therefore, we have to use this. But if the question is what is the magnitude of the magnetic field, then you have to use this formula. Now, in this case, if magnitude, then you need the value of the charge, the velocity magnitude, the magnetic field magnitude, then the angle between them. But the question is, what is force? So to do it is, of course, we need the charge. So if whatever charge given, then put it there. If it is negative, you have to place negative. Since it's positive, so I put positive. Then this should be multiplied by the cross product of the velocity. But velocity, take note, is directed towards positive x-axis. Therefore, the velocity vector is the magnitude of that velocity. If the velocity is given, let's put it there. Then the direction is towards x-axis, positive, so it should be positive I hat. Then we will take the cross product of this. Take the cross product of what? The velocity. This is according to the formula. Now, velocity in terms of unit vector, it should be the magnitude of the velocity. Magnetic field. The magnitude of the magnetic field multiplied by the unit vector, which is the direction of the magnetic field. Now, this, in this case, this is positive k hat. So we have to multiply. We have to take the cross product, the velocity vi, towards the b multiplied by k hat. So why is it that this is b k hat? B is the magnitude of magnetic field. K is the direction of the magnetic field. So be careful on the unit vector. Okay, remember, unit vector, the magnitude is 1. So if you multiply this unit vector with velocity magnitude, it doesn't change. The only purpose why we need the we have this I hat, because we express the magnitude and direction of that velocity, because that is according to the problem. Okay, so also with the magnetic field times its unit vector, whose magnitude is 1, and this is directed towards positive z-axis, which means that if this magnetic field is directed in reverse direction, then it follows that this is negative k hat. So therefore, this should be negative b k hat, and also with velocity. So before you solve, make sure that you understand the problem on what direction that the vectors directed, and also its magnitude. So this is, in order to calculate the force, then we have to simplify this. To simplify is, take note that q, velocity, and b here are scalar quantity. We have only, the vector quantity is only I hat and k hat. So for simplicity of the calculation, we can pick out all the scalars and put it together by multiplication, then leave the two vectors. Now notice that in vectors algebra, the cross product, again, the orientation, the position of the unit vector are very much critical. You cannot interchange this by simplification or manipulations. So we have to follow the order. So this should be I cross k. Okay. Now, the question is, what is I cross k? So you have to recall your vectors analysis. What will be the result if we take the I unit vector cross to k hat? Okay, so in order to answer, we have to recall the right hand rule. Now remember, in right hand rule, it should be x-axis, and we have the I hat towards the y-axis, and the result is k. Now notice that this is a counterclockwise. If you use the right hand rule, the rotation, the positive angle should be in counterclockwise. Similar in our Cartesian, diba? The standard angle is coming from positive x in the region 1, quadrant 1, then towards the quadrant 2, the angle is positive. Now if the rotation will reverses, quadrant 1 to quadrant 4, then the angle is negative. So in the right hand rule, if you stretch your thumb and your index finger, and you have the center finger, the index, if you call this as x-axis, the next should be y-axis, and followed by z-axis. So the angle is positive. Now, look at this one. Using this result, if you take the I cross K, look at the direction. What is now the direction of the angle? If you move from X, which is I hat, towards K, the direction of the angle is clockwise, which means it is negative. So the negative means that the answer of the I cross K should be a negative value. Now, what is the amount if we take the I cross K? So, very easy. The missing dimension here is J. So, the answer is already J. The question is it positive or negative? Then the answer is, look, what's out the direction of the angle? So, the angle again is clockwise. So, it should be negative. So, the answer, this one should be a negative J hat. So, you have to recall your vectors analysis in order to answer this properly, this problem. So therefore, the answer is the product of the three scalars, Q, V. Take note that V is already a scalar because it's magnitude. Magnetic field B is also magnitude. And we can multiply this. And remember, this is positive in this problem. But if this is negative charge, the input is here negative. So then, you have to multiply the product of this by the unit vector. And the result is, we have this. And this is the answer to the problem. Which means that the magnitude of this force is just QVB in the direction towards negative y-axis. Because this is J hat. And this is negative. So therefore, look at the figure. The angle, the velocity, the force should be in the negative y-axis. So you can use your right hand rule, look at this one, in order to answer it properly. If you call this as velocity and this is magnetic field, then the next is force. If you call this as the velocity, the index finger and the center finger should be the magnetic field. And the third finger, which is now in the thumb, because we have only the index finger, the center and the thumb will be your force. Okay? So, the magnitude is just disregard negative because remember the magnitude are always positive. So, remove the negative sign, then we have this QB. And the direction is, take note, is negative y-axis. So, that's it, no? If these are given Q, given the velocity, magnitude, and the magnetic field, then you can evaluate this problem. Okay, so now, as I've said, we are working with 3 dimensions. Now, look at the formula. The formula says that the velocity cross product with magnetic field with the Q, the answer is force. So, if we have this velocity, for example, then we have this magnetic field. Remember, the angle is clockwise, counterclock. So this should be, force should be in a positive direction. Okay? Which means that if this angle is in a counterclockwise, this is a counterclock. Sorry. This is a counterclock, meaning it should be a positive. Now, if this angle is a clockwise direction, then this force reverses its direction. So, we have to be careful on the orientation. Okay, now, as I've said, again, for these 3 components, velocity, magnetic field, and force, you can use your right hand rule again. So, look at this one. You can assign this index finger as your velocity. Then the center finger should be the magnetic field, and the thumb should be your force. Okay, now remember that this thumb is always perpendicular to the plane generated by the velocity and magnetic field. So this is always perpendicular to this plane. Now this angle P, it can be any angle. It can be acute angle, obtuse angle. Okay. Now take note that the formula is sine of that angle. So there must be positive, there must be a negative on that result. So in first and second quadrant, meaning from 0 to 180 degrees, the sign function positive. But if it is more than 180 towards 360, then it's already a negative value. So therefore, very important is the direction of the angle P. So again, in order to verify, by the way, the right hand rule is very important. Although this is not part of the calculation, but we can provide the direction of that force using only our right hand rule. Okay, so means the right hand rule is true to positive charge. If it is positive, then the result of the right hand rule will be followed strictly. Now, if this is negative, suppose it's negative, then the result of the right hand rule, whatever the result of the right hand rule, you have to reverse the sign, which means that if according to the right hand rule, F is positive, force positive, then if it is a negative charge, then the direction of force is in negative opposite direction. Okay. Or you can use your left hand rule. The left hand rule will be used if we have negative charge, and the right hand rule will be used if we have the positive charge. So either of the two, you can use it. So again, we can apply the right hand rule just for the direction. We cannot calculate the magnitude of that. So for magnitude, then use this formula. If the question is calculate the magnitude and direction, then you can use this formula. Or you can use this velocity. If the problem has x and y z-axis given to the problem, then you are forced to solve it in a vector part. Now, if there's no assignment of x and y and z-axis, then the magnitude can be calculated using this formula, the magnitude of the force, and the direction can be taken from the right hand rule. You have to justify your answer. Okay, but as I said, if there is given the problem, the y and x-axis, do it in a vector form. Okay, so look at this one. Another way, aside from you're given right hand rule that the index finger is velocity, the center finger is our magnetic field, and the last or the third, the thumb will be our force. Alternatively, you can also take the thumbs up. Okay, the thumbs up means the thumb still the force, but the curl of your finger, the 4 fingers, 1, 2, 3, 4 fingernails, the curl of your finger will be the direction of your angle. Remember, the angle is coming from the P is coming from velocity towards the magnetic field. So therefore, you have to use your right hand rule, curl it, then stretch your thumb, and that will be the direction of the force. So look at figure 1 or figure A. This one. The force is the velocity is green in this direction. Then we have this magnetic field. So the angle is, take note of this, is tending to move in a counterclockwise direction. So if you align your fingernails, so the strategy is you have to align your fingernails in the direction of velocity, then curl it towards the magnetic field. So if you curl it towards magnetic field, so this is the magnetic field and this is your velocity. You have to align your fingers in the velocity, then curl it towards the magnetic field, then stretch your thumb, and that will be your magnetic force. Okay, if you do it, then it's good. Look at the next figure. Where is your velocity? The velocity is what? Here, green. And the magnetic field is, we have this. So remember, this is counterclockwise, or this is a clockwise direction. So all you need to do, place your finger in the magnetic field, but you cannot put it in that way, because if you do it this way, the curl is opposite to the angle. So all you need to do is to reverse your thumb or your hand this direction upside down, then you have to curl this because we are, the strategy is align your fingernails, the four fingernails, towards the velocity, then curl it towards the magnetic field. And notice your thumb is directed downward. So this is 2. Okay? So we use the right hand rule. Take note because this is positive. Now what about in negative? In negative is, you can use your right hand rule again. You can do it. But whatever result in right hand rule, reverse the direction. And this is true to this figure. By the way, this topic requires your knowledge of this right hand rule. I tell you, very important that you know the right hand rule. There are 2 right hand rules, diba? You can stretch, you can use the 3, or you can use all. But we use the angle. If you use 3, meaning the velocity, magnetic field, and thumb. Pero if you use this thumbs up, we need only 2. We have the force, which is the thumb. The curl is the angle. But take note, the angle is coming from velocity towards the magnetic field. Okay, this figure is taken from the book of Young and Friedman sa University Physics. Okay, so right hand rule. Okay, now, as I've said a while ago, that this problem works on 3 dimensions. Now, this is difficult for us to picture out in a 3 dimension. So we tried it, construct the figure for simplicity, convert this 3 dimension into dimensional drawing. How to do it is, of course, the plane of our paper is covers only 2 dimensions, but the 3rd dimension is towards you, or towards the paper will be the 3rd dimensions. Okay, so for example, this figure, how to construct this in 3 dimensions, where x is, remember, velocity travels along x. This is our problem before. Then the velocity, the magnetic field is on the z-axis. Then the y is in the x-axis. So how to convert this into 2-dimensional problem? So if I assign this xy, remember our velocity, our charge is here. Then the magnetic field, look at the magnetic field. The magnetic field is along z-axis. So it should be normal to the area, the plane of xy. So remember, this is xy, z, xy, positive x, positive y. So therefore, the z must be towards you. It should be towards you. Why? Because we use the right hand rule. If you use the right hand rule again, curl your thumb, your fingernails from positive towards y, then stretch your thumb. It's towards you, which means that the positive z-axis should be towards you. So this problem, again, the magnetic field is towards positive z. That's why I put it here, dot. The dot means the tip of the arrow. Remember, look at this one. The magnetic field is a vector. So it has a tail, and we have the tip of the arrow. The tip of the arrow will be the direction of that. Okay? So if the arrow is pointing you towards you, remember, the z-axis is towards you. Look at the dot product. Dot here, the red dots. It signifies the magnetic field. Remember, magnetic field are not only one. Okay? It is composed of magnetic field lines. So this one represents only the magnetic field that acts on the charge. But whatever magnetic field here is the same throughout the span, according to the problem. It can be varying magnetic field, but in this case, let's start with a constant magnetic field. So the magnetic field is towards you. Okay? So that's the meaning of the dot means towards you. Now if this is x, you can say x, or if this magnetic field is towards positive z-axis, then change this to x, meaning the x is the tip of the arrow. Remember, the arrow, just like a bow and arrow, diba? At the bottom of the arrow is a kind of flight, diba? We have the flight. It guides the direction so that it will move in a straight line. So we need the uh, tail of the arrow, which is in the form of X, just like a dart pin. The dart pin, the bottom part is two wings cross each other, so it's a cross actually. So for the sake of presentation, the dot means the tip of the arrow. Now if it is moved, meaning it is towards you, but if that away from you, meaning towards the plane, you have to put it X. Okay, so in that case, so if we have this charge, where is your velocity? Velocity is towards the x-axis, so we have the VI again. And your magnetic field is towards you, magnetic field. So if you use your right hand rule, look at this one. If you take the cross product of the I cross towards you, which is K hat, then the answer is negative G hat. So therefore, the force should be, okay? So this drawing now is in 2 dimensions, and this is in 3 dimensions. Most of the time in our problem, we are working in 2 dimensions. So in the book of Young and Friedman, are always illustrated in a 2-dimensional figure, but it can be analyzed in 3D. Why 3D? Because XY is the plane of the paper, but towards the paper or out of the paper is our Z-axis. Okay, now the Z-axis can be velocity, or it can be force, or it can be magnetic field. So you can assign, magnetic field can be assigned along Y or along X. The force can be assigned along X and along Z also, vice versa. Okay, so this figure, look at this one, to exercise ourselves on how to convert the 3-dimensional drawing into 2D. Suppose I have this charge, negative Q, a negative charge. Then we have this X again for our Cartesian, standard Cartesian, the Y. Now remember, this is a dot, so meaning the magnetic field is towards positive Z hat. So still we have this BK. But if this is X, these are all X, meaning the bottom of the arrow, then use the negative BK hat. Okay, so suppose this charge travels in positive dimension, positive X. So this is VI hat. So the question now is, where is your force? So take note that to answer that is, theoretically, look at this one, according to the formula, since the velocity is towards X and the magnetic field is towards Z-axis, so the plane is XZ. So therefore, the force should be along Y. It can be positive or negative. But in that case, is it positive Y or negative Y? We are very sure that the Y is lying along the Y. The force is lying along Y-axis, but is it positive, towards positive, or towards negative? So to answer is, in that case, you can use your right hand rule if you want to, or you can use the formula. If you use the right hand rule, remember it is negative. So again, the instruction is place your fingers, okay, this one, 1, 2, 3, 4, 5, on the direction of velocity, then curl it. Please do it. Place your fingers, the 5 fingers, in that direction, in that manner, then put that finger direction towards the velocity. Okay, do it towards the velocity. Then curl your 1, 2, 3, 4 towards the magnetic field. Remember, the magnetic field is out. Then what will be the direction of your thumb? Remember, it's difficult for me. You have to place it in opposite. Then, since a magnetic field is not in that direction, it should be here. So notice that this thumb directed downward. Okay? So the right hand rule give us the idea that the magnetic field or the magnetic force is directed towards positive J hat. But take note, it is negative charge. So the answer of the right hand rule will be the correct answer of the right hand rule, or in the right hand rule answer, because this is negative, you have to reverse the answer of the right hand rule. If it is downward, then the correct answer is upward. Why? Because this is a negative charge. So in other words, in that figure, in 2 dimension, wherein we have the velocity along x, positive, and we have the magnetic field along z axis, your magnetic field again is upward. Why? Because the right hand rule is downward. Okay, you can also use your left hand. So the left hand still, the same orientation. Curl your fingers in the direction of the magnetic field. Oh no, in the velocity direction along positive y or x. Then curl this towards you, or out of the paper or the plane. Then your thumb, take note, stretching upward. So therefore, you use the left hand and you answer this problem, meaning the force is directed positive y. You have to you use the left hand rule. So you can use right hand rule, right or left, okay? But if you stay on the right hand rule, for me, I stay always on the right hand rule. But I notice the charge. If the charge is negative, then I will reverse the answer of the right hand rule. So I did not use my left hand, okay? Because the rule is right hand rule. Okay, this one. Okay, another. Take note that, what is this? The force, take note, is along z-axis. Okay? So the given problem is the force is along z-axis. Why z? Because take note, the problem is this is along x-axis, positive here, negative, and y is upward and downward. Then this one should be along z. But because this is x, meaning this is the bottom of the arrow, the wings of the arrow, which forms an x. This one, the dot means the arrow is towards you. This x means that the arrow is moving away from you. So this is now 3D. Okay? So, if this is the direction of force, and this is the direction of velocity towards negative x, the question is, where is the direction of the magnetic field? Take note that previously we find the direction of force, diba? Now this time, what if the velocity is given and the force is given, and you are looking for the direction of the magnetic field? Now to answer, you can use your right hand rule again, or you can use the formula, right hand rule formula. So for now, at least if you want to know direction, you can use the right hand rule. Place your, again, your because positive, so the answer of the right hand rule is correct. Do not reverse. So place your fingers towards the negative x in direction of velocity, and remember the thumb is force. So the thumb is already at the upper part around x. So therefore, what will be the force is towards the what? Towards the negative z. Okay? So the force is towards z. You have to align your thumb towards negative z. Okay, that's it. Towards the plane. And you will curl, diba? You are forced to curl your finger, the 4 fingers above, which means that the magnetic field is positive y-axis, directed in the positive y-axis. So this is true only if the angle, okay, this one is 90 degrees. But there are cases na this is not 90 degrees. The angle between the velocity and magnetic field. Okay, so again, this is how to convert the 3-dimensional problem into 2-dimensional problems. But we can analyze in 3D because towards you and away from you is the 3rd axis. In the drawing, we see only 2 dimensions. Okay, that's it. So here comes the problem. And this is the problem. This problem is very prone to you for the exams that I give you, quizzes, problem sets. Okay. Suppose the problem says that calculate the magnetic force. The word magnetic force means you have to present that in a vector. You are forced to use the vector y because given the x-axis, y-axis, so two-dimensional drawing. But take note, this is a 3D. Okay. Suppose the problem says that the particle is placed in the presence of the magnetic field, wherein the magnetic field has a magnitude of 4 Tesla, and because this is dot, okay, that means what? The tip of the arrow travels towards you, towards your eyes. Okay? So, it is positive what? Positive z-axis. Okay, then, this charge is negative. And this charge travels in negative axis. It can be traveled positive, but this problem says this charge particle travels negative. And the magnitude of that is 200 meters per second. And the charge is negative 8 microcoulomb. Okay, now, the question is, how much is the magnetic field? Meaning, magnitude and direction. So, you have to use this formula. Okay? This vector formula. So, all you need to do is, again, to solve for f, question mark. What will you do? Look at the formula. First is the charge. So, place the charge here. And this is negative 8. But this is micro. So, you have to multiply times 10 raised to negative 8. Then, you have to multiply the cross product of the two vectors. Okay, notice that the velocity vector, the direction is towards negative x, which means that this is the magnitude of velocity is 200 and the direction is I hat, and this is negative I hat. Remember, the magnitudes are always positive. Now, this negative is the negative direction of I, meaning you multiply the 200 magnitude by the unit vector, but the unit vector is negative I hat. So, therefore, this becomes negative 200 I hat. And you have to take the cross product of this one for T. T means Tesla unit. So, you can ignore it because T is already SI. So, once the given are in SI, you can disregard the unit, eliminate for the sake of calculation in order not to complicate. Then, take the cross product of that, and this is 4K. Why 4K? 4K because what? It is towards you, z-axis. Okay, so we have here, now as I've said a while ago, that these are scalars. The 8, negative 8 times negative 6, the negative 200, the positive 4 are all scalars. Then, you can multiply it all. Negative, negative becomes positive, and this is positive. So, therefore, we have 8 times, this is not 6.4. So, this is 8, change this, 8 times 10, so remove the 6.4. Unya, this is exponential format, diba? Times 10 raised to negative 6. Okay. No. This is correct. So, 8, and we have to multiply that by, this is 8 times 10 raised to negative 6 times 200 times 4. So, this should be the result. Okay, what is this 6.4? I think the 6.4 is not the real. This should be 8 times 10 raised to negative 6 times 200 times 4. And this is I cross K. Okay? What is I cross K? The I cross K means a negative. This is I hat, a J hat, diba? What's missing over here? The missing is J hat. But the question is it positive J or negative J? Now look at the orientation. You are rotating from I-axis to K-axis, or from X-axis towards the Z-axis. So it's kind of clockwise. So therefore, it should be negative J hat. So again, recall your right hand rule. you are rotating from I towards K. So it should be negative J. This is similar to our previous example. So therefore, this is, by the way, this is 6, okay. The 6.4 is already the product of the 3. A times 10 to 6 times 200 times 4. So it is a typographical error. So therefore, this is 6.4. You can verify your calculator if this is correct. Multiply this 3, 1, 2, 3. Then the result is 6.4 times 10 raised to negative 3. And this is negative J hat. So therefore, the answer is negative. 6.4 times 10 raised to negative 3. J hat is the answer to the problem. So the correct answer of this, the angle, the force is directed towards negative J. And the magnitude is 6.4 times 10 raised to 3. So this answers to the problem. Okay, now here comes the worded problem. The problem says that we have a particle with a charge of negative. This is a single charge particle whose magnitude is negative 1.24 times 10 raised to 8 coulomb, is moving with instantaneous velocity, meaning that velocity is velocity at that instant. Okay? And the velocity is given in terms of I hat and J hat, which means that this is not lying strictly along the x, positive or negative x. It's not along in one dimension. It is moving in two dimensions, in along x and along y. But this is negative. So negative means this component is in negative y-axis, while this component is along positive. So therefore, this velocity is in the fourth quadrant in the Cartesian. So the velocity is not exactly along x. It is in the fourth quadrant. Is it correct? Fourth quadrant. Okay, positive x, then downward is, so therefore it is the fourth quadrant. Now the question is, what is the force exerted on this particle by a magnetic field? So how much force exerted on this particle by a magnetic field? Letter A, the magnetic field is 11.4 Tesla, and this is directed towards positive x because this is I hat. Okay? Now in letter B, you are asked again, but this time the magnitude, again, the same magnitude, 11.4, but the direction of the magnetic field is along z-axis. So there are two answers to this. You have to answer letter A separately with this magnetic field, which is directed towards x, and the velocity is here. So the velocity is already given, and we have the charge. So this is actually a matter of direct substitution. In letter B, almost the same process, except that we have this k hat. Okay, so pick up the given. The given to the problem is negative. You have to consider a negative. It's already converted. And we have this velocity given based on the problem. You can ignore this sign, this magnitude, meter per seconds, for simplicity. Okay, then this is now the situation. This is in the what? This is in fourth. Let us say this is in this is in 3D. Suppose this is in fourth quadrant, and we have this velocity, magnetic field, and this is for this force. So how much is this force? By the way, this is 3 dimensions, so you can ignore that. No? This drawing. Go directly with the formula. The formula says to calculate this force, you need what? Q, and take the cross product of the velocity vector and the magnetic field. So do it. Okay. So for A, you have to use this one, I hat 11.4. I had then substitute to that magnetic field, and okay, we have this charge, and this is the cross product, meaning this is the velocity, and this is the magnetic field based on this. So then all you need to do is to take note. The answer should be 2 terms. Why? Because this is a 2 term. So distribution process, you can distribute this by multiplying this first term towards here. Okay, then take the result, then this one multiply it here. Now we have two terms. The 2 terms will be distributed the charge. Okay, So for now, let's multiply this one by the what? But careful that if you multiply this scalar, and this one, it should be I, take the cross of I. So it's the order is, you start here, then take the cross of that. But what is the cross product of itself? This is I cross I. The angle is 0. What is sine of 0? 0. So therefore, this practically 0. No? If you multiply this, I times I is 0. But this one is not 0 because this is j. You have to take the j cross I. Okay? So that's it. So this will be the result. This one is the result after multiplying 14.19 times 10 raised to 4 with 11.4. And this is it. And this is I cross I. That's it. Minus, minus. So it is what? This one, 3.85 times 10 raised to 4 multiplied by 11.4. This is the result. Then we have to take the cross product, by the way. Double check this if this is correct. No, I think there is a discrepancy of this answer. There is a kind of exponential form. Just verify because this is positive 4 and this is, so obviously this should be greater than this. Okay, so this one also multiply this with 11.4. This is, I think there is something here missing. I lost the exponential factor. 10 raised to, I don't know, 4 raised to 5, 4 raised to 6. Then this is I cross I. So what is I cross I? This is 0. This is 0. Meaning if it's 0, this whole term becomes 0. But we still have this one. Now what is j cross I? If you take j cross I, you can imagine the Cartesian. The rotation now is coming from j to y-axis towards x. So it is a clockwise, the clockwise direction. So if it is a clockwise direction, then it is negative. So the missing here is k. We are very sure that the answer of this is k. But is it positive or negative? Look at the direction. This is clockwise. So for clockwise, it should be negative. So this is negative k hat. But negative k hat, okay, this is negative becomes plus. But this is negative. So the answer is negative 4. 5.44 times 10 raised to 7. Kindly verify this answer if this is correct. Okay, again, for your you have to verify this if this is correct. What will be the times 10 here, and also this one. Then this is 0, so nothing to worry with this. Then multiply this with this one. Then verify this exponential form. Is this correct? So these are the answers, or this is the answer for letter A. For letter B, of course, the only changes here is this one. Okay, change this to k hat because the problem is k hat. So replace this with same number, 11.40 times 10. Okay, then we have k hat. So the same process, but take note of this. If you multiply this with this one, this is I cross k, non-zero. And this one, j cross k, non-zero also. So expect that we have two terms here. So if you do it, again, double check this one. I did whatever the result here is the same magnitude, but there are changes in terms of the unit vector. And also this one, verify this. Multiplying 3.85 times 11.4. Now what is j cross k? It is a counterclock, and the missing is x, so meaning this is positive x, a positive I hat. And this is I cross k. It is a clockwise. The missing is j. So clockwise means negative. So it is negative j. So therefore, this is the result of here is 1, and the result of this is 3. We follow the order. It should be ascending order. I, then j, k. So I change the position. This is negative. Negative becomes plus. That's why this is positive. And this is negative. But negative times negative becomes plus also. But this is j. And this is the answer. Kindly verify this answer. If this is correct, I think this is only the wrong portion, but this is correct. Just double check. Okay. So we discuss how to calculate. We give the formula. We convert the 3 dimensions into 2-dimensional drawing for simplicity. and we are able to use our right hand rule for positive charge, and you can use the left hand rule for negative, or you can stay on the right hand rule then reverse the answer. And we provided with the formula, or with the example in how to do it using right hand rule, and we have here the calculation. So all you need to do is to continue, no? Solve problem for your practice. So we have here the problem set at the same time assignment. Solve problem 1, problem 2, okay? And we have the problems taken from the book Obiang and Friedman. And there are answers here in the online. You can verify the answer. Okay, so all you need to do is to do it in order for you to answer. Okay, so that's all. Thank you for watching. Study is the key to understand. Bye bye.